Let's do this really hard problem. The question is basically asking if there's a suspension system, this car, it sags 11 centimeters when this chassis is placed on it. And it says that the oscillation amplitude decreases by 59% each cycle. We can actually represent that as saying that x2 equals, if we were to go, 100% minus 59%, we'll get 41% out of that. So that's basically, the second one is going to be 41% of the first one, 0.41, and that would be something like that. So that's how we can represent that equation. And we just have to sort of, I think we could solve for k right now. We'll deal with that a little bit later because I'm gonna need k. So let's look at this again and realize that there's a spring force going this direction. I think we can represent that as kx. And then remember, there was that force of gravity coming this direction from each one of those. Well, each weight is divided into four, because you got 1900 kilograms divided that into 4 bits. So each one of these is able to hold 475 kilograms. We could set them equal to each other. So let's just say mg equals kx. Divide x on both sides. And you're going to be left with mg over x equals k. So let's just figure out what k is real quick on the side here. This is just an approximation though. So it's 475 times 9.8, divide that by 0.11, and I get this crazy number. So it's 465,500 divided by 11. That's actually the correct answer. All right, cool. And this is newtons per meter. Okay. Now, let's move on to trying to figure out what B is. Well, remember X. And X can be represented, we had that formula that was the X is represented by our amplitude times the e to the negative bt over 2m. This is for a damping harmonic motion, damped harmonic, like that, damped harmonic motion is this little section right here. And then we have this, the rest of this, which would be, cosine w prime t plus this. Keeping in mind that we can actually just isolate this section out, call this x equals xm, e to the negative bt over 2m. I'm not 100% sure why we can do that, but it's just like, you can just do that. So anyway, the point is that you could say x2 is equal to xm, and this is always going to be xm. We'll see that's going to cancel. It's nice. But here we have this negative bt2 divided by 2m, and then we can divide that by x1, and that's going to be xm again, e to the negative bt1 divided by 2m. Let's take a look back at our original equation here. And let's just do some rearranging. Let's just go x2 over x1 equals 0.41. That's pretty cool. We can actually just go ahead and set that over here equal to this. Let's cancel out these x's and get rid of that. And then we can rewrite this a little bit better. Consider here our t's. Keep in mind these are equal here, right? And they're t's. This is a t2. That's going to be our period. We kind of have to figure out what the period is over there. T1 is obviously going to be 0 for this particular thing. If we do that, this is going to be e to the 0 power, which is equal to 1 on the bottom. So far we have this. x2 over x1 equals 0.41. which is equal to, this goes away and becomes 1. And then we still have the e to the negative b t2 over 2m. We don't know what the period is. So what's the period? Period is just 2 pi over w. And w is equal to the square root of k over m. Alright, we're getting there. So if we were to do that with our new thing here, let's plug that into the calculator. M is going to be 475 kilograms, and the K is just that. I'm going to plug that into my calculator over here. Square root of 46,550 over 11 times 475. And I get 14 square root of 55 over 11 radians per second. And that's what's going to go under the 2 pi over here. We can say that 2 pi divided by that is actually it's 0.666 seconds. Yeah, it actually is. So anyway, so the point is, let's plug that in for t2 over here, and then what we can get is this equation. We'll solve for b real quick. Let's put ln on both sides. So ln of 0.41 equals negative b t2 over 2m. Throw the 2m on the left side, 2m. ln of 0.41 equals negative b t2. And we can just divide t2 from both sides. We're going to be getting things like, negative b equals 2m ln of 0.41 divided by t2. And if we plug that into the calculator, then we'll get, just double checking to make sure this is all right. So we'll go 2 times 475, this again 475, and then this one was 0.666 seconds. I'm going to use exact numbers here though. And then here's the ln 0.41, and then divide that by, it's not t squared though, it's not t squared, it's t2. Okay, and then that's the answer there. Well, it's going to say b equals 1272.41. That should be the correct answer, 42 or something like that. And this is kg over seconds, I believe. So that's kind of an interesting equation. Yeah, a little bit rough. I think understanding this, how to set up this ratio is really important, because that would give you the correct setup here, and understanding how to pull this little piece of the puzzle out, and then understanding this mg equals kx, that was key as well. So a couple of different powerful equations here, and hopefully that was kind of fun.